Hi, my name is Steve Sutton from AIS Construction Equipment, and we've produced this video today to help you maybe answer some questions about charging systems, help you troubleshoot them, and maybe help you understand them a little bit better. First of all, what we're going to do is try to equate the theory of the charging system to an actual water distribution system in a small town or village, we'll say. And right here, we've got a water tower. It goes off like this. Now our water tower is full of water. Now the job of the water tower is to store water for use on demand. Now we also need to be able to use that water, so I'm going to build a little house right here. Little cute little window, put a little door on it. I'm going to put a standpipe in my water tower up to my house. Now, here's my storage. Here's my water being stored. Here's my load, or my demand, if you will. So the water tower is supplying water to my house, or my network of stores and schools and factories, if you will. I just put a little house there. This all works fine and dandy, because when we turn on our water system on our house, we turn on the sprinkler, we turn on the dishwasher, we flush a toilet, whatever we're going to do, we take a shower. What's going to happen to our water tower level on our water is it's going to go down. And then here's again, that all works fine and dandy until the water tower is empty, and we need to pump that back up. So here we have a pump house keeping our water tower full. Here's our water tower, which is our storage, and here's our demand, or where the water is going to be going to. As the water gets used into over here in the town, the water level goes down. The pump house turns on and keeps the water tower full. Remember, this is like an old water tower system here. Okay, now let's talk a little bit about sizing the components with each other, or the system together. It all has to work together as a system. So I have a pump house here. The pump house really has to be sized to the water tank and the system. The water tower, the water tank here has to be sized to the community. You can just imagine if I had a real big community and a little tiny water tower, that I wouldn't have enough reserve, or when my pump is not running. I realize this in pump community, they're running basically all the time, but in our case here, when we go to equate to the charging system, it is not always running. If we have too small of a water tower, it can't supply the community. And it may, depending on what you're doing here, overwork the pump house. There's no use putting too big of a water tower in, because you don't have that much real estate and it costs more money. You don't have that much room for a big water tower. So it really has to be sized according to what the loads are, what the demand is. Okay, now let's name our electrical components. We know that's not a pump house, because there's no pump house in our electrical system. That is our alternator. This water tower, our storage system, is our battery. And we do know from a previous video that a battery does more than just store. It does produce it, but for our charging system, we're not worried about that. We're going to look at this today as just a storage facility. And then we cannot talk about this as our water system or our electrical system, because the whole thing is part of the system. This is just one part of the system. So we're going to talk about this as the loads. Being there's more than one load. The shower is one load, and we're not worried about just one shower. We're worried about the toilet, the dishwasher, the water faucets, everything as a combined as part of our loads on our electrical system. Okay, now let's talk about sizing the components a little bit. Now, it's not like you're going to just take a piece of equipment and design it and put, well, what size alternator do I want to put on this? What size battery? Things like this. But it's when you start adding components to it, or you start having failures, like you're going through alternators, and what's really going on with it, and why does it have a certain battery, and why does it have a certain alternator, things like this. So let's for the heck of it, for the sake of argument, I'm going to call this a 90 amp alternator. That is rated at 90 amps. It will produce 90 amps, but not for a sustained length of period. It will peak, it will run there at 90 amps for a while, but not sustained. It is rated at 90 amps, and if you take half of the battery, of that amperage rating, take half of that, which now equals 45 amps, that is designed, that 90 amp alternator is designed to sustain a 45 amp load over a long period of time. It will produce 50, it will produce 60, 70, 80 amps, but the longer it produces more amperage, the shorter the life of that alternator is expected to be. Now the water tower, I'm sorry, it's not a water tower, it's a battery. The battery, we need to have a big enough battery to take on the amount of load when this is not running, for one thing. For example, if we put, let's go back to our water tower for a second. We put too small of a water tower in our community, when this is not running, we run our water too quickly. Same with our battery. We may not have enough battery to even start the vehicle or run the lights if you want to for X amount of hours or time without the engine running, things like this. There's no use putting too big of a water tower on. Space in a mobile vehicle is very critical, so we're not going to put any bigger battery than what we really need either. So that's why our battery is sized physically the way it is. There's more that goes into sizing a battery as far as reserve capacity and cold cranking amps. That's another video. Okay, let's look at doing some basic checks to the charging system with using just a voltmeter. First thing I'd like you to do, we're going to take a voltmeter reading with the machine shut off. I want to know what is the level of water or charge in the battery with this just sitting there. It is not unusual whatsoever to see a 12 volt battery with 13, 13.2. It might be 12.8. If it was as low as 12, 12.4, it might be a little on the low side, but it's not unusual to see about 13. So let's just say we have about 13 volts in our battery just sitting there not running, just sitting there static. We start the engine up, so in other words, we start our pump house, we start our electron pump up, and we're going to start to charge the battery. Give it a minute or two to stabilize, and we should see, and actually you should see in all reality within a few seconds, anywhere from 14 to 14.5 volts on your voltmeter when it is running. That is not unusual to see that much. That is entirely normal. If you see upwards around 15, 14.7, maybe 15, something like this, then you might be experiencing an overcharging situation, and we need to have that looked at. Now, remember, we're sitting here running idle. The key thing is we saw more voltage running than we did not running. That's the important part. Rev the engine up, whether it's governed or just run up a couple thousand RPM, just rev it up. We want to make sure that voltage doesn't get out of hand, like I say, at about the 15, 14.8, 14.9, because then you may be looking at overcharging and start boiling batteries out. Okay, so now we've got our check. We did it static, we did it idle, and we did it on high idle or mid-range engine speed. Now, let's start putting some loads on the system. We're going to turn the wipers, we're going to turn on the air conditioning, we're going to turn on the four-way flashers, we're going to turn on any kind of lights, anything we have. If you want to beep the horn, you can do that too. The more electrical loads you put on, the better. So what we're going to do in our water system, we're going to turn on all the faucets in town, or in this case in our house. We're going to turn everything on, and we want to make sure our system, our pumping system can keep up with that. Look at your voltage. Look at your voltage. If you drop a few tenths, I'm okay with that. But the big thing is you need to stay above this static voltage. If you start dropping down below 12 or 13 in this case here, you say you drop down, you load everything up, you drop to 12.7. What that tells me is this alternator is not keeping up, and you're starting to dump out of your water system. You're starting to deplete your whole water supply because you don't have enough pump going on here. Okay, now the true way of checking a charging system is to use an amp clamp or some method of measuring amperage or the flow. Just like when you're checking a pump out, the really true way of checking that pump is to see how many gallons per minute, how much flow is coming out of it. So we are going to attach an amp clamp right here on around our wire. We'll talk about what the amp clamp is here shortly when we get out there in the shop. And we're going to be measuring the amount of flow coming out of our alternator. Okay, we've got our amp clamp on, and we're going to start the machine up. We're going to start the machine up, start the engine up. Don't be surprised if that goes fairly high, maybe even a little higher than half of the rated amperage of the alternator for just a few seconds, because that's just recouping what you've used when you went through the cranking process. Give it a few, I say a few seconds, and maybe even a few minutes to stabilize, and you're looking at what it's charging or what its output is. After things stabilize, there's a lot of variables going on, but I would expect somewhere between 5, 12, maybe 15 amps. It's 5 to 10 amps, something like that, of charge be there at all times. Even you say there's nothing going on. Well, there are things on that you can't control. Now, start turning loads on your vehicle. Lights, radio, wipers, all this, anything electrical component, and you're looking for what at the amperage is coming out of the alternator. You may run this up, it may run to half, it may exceed that, then that's okay, as long as there again, if you're at 5 items and you exceed it, go back and look at what you're running. If the operator's never going to run only but 3 things and you stay below that half, you're probably good to go. But if it's like the plow truck, plow lights, wipers, heater, strobes, any kind of controllers that they're running there too, if that starts exceeding and pushing that rating of the ampere of the alternator, that's where you start getting into trouble and you start shortening the life of your alternator. Now the true way, or a true method I should say, a true method of establishing what your demand is on your system is shut the machine off, turn on everything that you're going to have on that you possibly can, everything electrical that you possibly can, use your amp clamp and put it on the output of the battery cable. It does not matter which cable you put it on, the positive or the negative. You put it on and check what your flow is out of your battery, powering up everything. Suppose we want to know what is our alternator capable of putting out, as in that is the maximum it's capable of putting out. It doesn't matter if it's a 90 amp or 120 or 80, it might be 90. It's only capable of 60, something like this. So what we're going to do, we'll do this out in the shop too, is what we're going to do is we're going to put such a big load, we're essentially going to take our water system and we're going to open up the fire hydrants, every faucet in town, and we're going to just dump put such a high load on the system, it's going to put that out to maximum. And how are we going to do that? We're going to take a load tester, we're going to put a battery load tester that has to be capable of drawing more current than what the alternator is putting out. We're going to crank that down and we're going to see what its maximum output is out of the alternator, whether it be 40 or 20 or 200 or whatever that may be. So, to recap here on our tests, we're going to put a voltmeter on it. We're going to check our static voltage, shut off. We're going to check our charging voltage at an idle. We're going to check it at high idle, make sure we're not overcharging. We're going to load the system down. That'll give a pretty good idea of what our system is capable of based only on voltage. Then we're going to take the amp clamp and we're going to put on the alternator discharge, the charging wire of the alternator, and we're going to see what the alternator is charging. We're going to load it up and make sure that we're not overloading the alternator. Then we're going to dump, or we're going to put the load tester on the battery and load our system right up and see what the maximum is out of our alternator. From AIS Training Center, I'm Steve Sutton.
And I'm Joe Thompson.
Work smart
and work safe.